Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the change in entropy of a gas when 15 grams of CO2 gas are allowed to expand, or gas molecules, sorry, are allowed to expand isothermally from 1.0 dm cube to 3.0 dm cube at 300 Kelvin. So the first thing you have to do is to write out the parameters. We're told the mass of CO2 gas is 15 grams, right? We're also told that this is an isothermal expansion, so the change in temperature is zero, or the temperature is constant throughout the entire process. And we're also told that we have an expansion, so the V initial is 1.00, sorry, just 1.0 dm cubed. Okay, and then the V final is 3.0 dm cubed, and the temperature is 300 kelvins. So this is a very, very important question. Let me just rewrite the 1.0 again. 1.0 dm cubed. One thing you have to know is that when you have a question like this, where you're told that that is an expansion that occurs isothermally or an isothermal expansion, and you're dealing with entropy, well, it's important for you to know the formula, that the formula for the change in entropy in an isothermal expansion process is NR ln V final divided by V initial. So this is basically, this is it. This is how it's done. So when you have this information, you can now go on to solve the question. Note that in our situation here, we're told number of moles, right? We don't have number of moles, but what we have is mass as well as identity of the gas. So the number of moles is going to be the mass divided by the molar mass. So the mass of CO2 divided by the molar mass of CO2. So the number of moles is now going to be, the mass is 15 grams, the molar mass of CO2 is simply 44.01 gram per mole. So the next thing, of course, you do is for you to 15 divided by 44.01 gram per mole. That will mean the number of moles is going to simply be 0.34091 mole. So that's basically how you do with this question. So you have the number of moles, you have R, and you have the V final divided by V initial. So you can just simply substitute to the equation you have. So you have the change in S, the change in entropy is going to be 0.34091 mole, okay, times the gas constant, which is 8.3145 joule per mole Kelvin, times ln V final divided by V initial. So 3.0 dm cubed, okay, divided by V final, V initial. So that's just going to simply be divided by 1.0 dm cubed. Of course, you cancel out dm cube, 3 divided by 1 is 3 for, so it's ln 3. So you have mole here as well and mole as well. So you have the change in a second. So you have the change in entropy is just going to be 0.34091 times 8.3145 joule per Kelvin times ln of 3. So of course you input all of this information in your calculator to get the change in entropy to be 3.114 joule per Kelvin. Now, I want to quickly mention something, that this is the answer to our question. But because in chemistry, we would use the number of significant figures that is the lowest from the information given in the question. We see that 2 fixed sig figs is the lowest. So we have to answer this question in 2 sig figs. So the final answer is just going to be 3.1 joule per Kelvin. So the change in entropy is 3.1 joule per Kelvin. So that is basically the answer to this question, 3.1 joule per Kelvin. So if you have any questions, please put it in the comment section. If you would like me to tutor you, I'm a tutor for any student who is trying to succeed in all their chem related studies in their basically their academic life. So if you'd want a tutor for all your STEM related courses, whether you're middle school, high school, or college level, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.